Hello and welcome to this webinar in the COVID Inspire Hackathon webinar series. Today we are going to learn about mapping. In fact, how we can make maps collectively using a whiteboard. And with me here, I have a panel of speakers, experts on this area. I think we can start as usual by giving a very quick weather report. I see we are a little bit ahead of time, so we can start by that. And let's learn where you are from and what the weather is like where you are. And I will start showing you how to do this. We want you to report in the chat, and in the chat is also where you're going to ask questions and comment. So, Runar, where are you and what is the weather like today?
I am in Brussels, Belgium, and the weather is like this.
Nice. No rain?
I don't know, rain. Well, maybe that's a bonus. There's no rain. I can say
that.
That is the good thing about the weather here. There is no rain.
Never rains in Brussels. Maybe sometimes. Okay, Raitis, where are you and what's the weather like where you are?
I'm right now in Latvia, and to be honest, I haven't been outside today, so I don't know how it feels, but but it looks to be windy and quite chilly, probably.
Probably quite chilly. Okay.
Yes. At least yesterday it was so.
Okay, yeah, that's the most likely weather is the same weather as the weather you have today is most likely to be the weather tomorrow. That's the truth. Carol, how about you?
I am near of Prague, some small city or village in Očany. It is on the border of Prague, and we have a sunny day, 20 degrees outside. But similar like this, I was not from the morning outside, so I see this only from window.
I see. Yeah. Well, that's the situation very often these days, where we are glued in front of our computers, having meetings online thanks to the COVID-19 situation. So my name is
Czech. We are almost close at our houses. Yes, there is more and more restrictions. In principle, we can go only shopping food and go to the nature. So all other is already prohibited.
Yes, we see pictures on the news of the Carlsbridge without no people on it, which is extraordinary.
No, but this is already from March, because foreign tourists stop to come to the Prague, and normal Czech people, or maybe not Czech but Prague people, if they don't need, they never go to Charles Bridge. Yes, because it is not very pleasant to go with this big stream of people normally. So maybe that sometimes now Prague people go finally to Charles Bridge.
Yes, to enjoy their bridge in peace and quiet. Yes.
But when you say that tourists stopped coming to Prague, I think it's honest to mention that Prague told tourists to stop coming.
No, but then it was at the beginning, but then it was allowed, but already people stopped to come.
Yes.
Well, I just remember seeing no foreigners for 6 months or something friendly like that was what I saw from Czech Republic at the start.
Yes. Yeah, so, well, I forgot to introduce myself. My name is Bente Lilja. I'm going to be your host today, and I'm delighted of the topic, of course, because in my former life, I was the research director of the Norwegian Mapping Agency. So this is super cool webinar for me. The weather here where I am, I'm in Norway, just northwest, slightly northwest of Oslo on the countryside, so we can move freely here. And the weather is gray, overcast, and it has been raining and it will be raining. It's getting darker and darker and darker every day. Yes, it's worse than in Brussels, Runar. Yes, ooh, happiness. František, welcome from, and you greet us from Pilsen. Nice to see you here, František. I think we can start on the program. I believe, Runar, are you going to start the show? And you can introduce yourselves, by the way, sorry, start over. Can you please introduce yourself and tell us a little bit about your background before we dive into the presentations? So Runar, you first.
Yeah, well, my name is Runar. I am Norwegian. Most people who have met me would predominantly describe me as very, very big. And I also talk a lot. I work in a company called Aspan Viak, which is unfortunately named Norwegian advisory company that does quite a lot of stuff in different sectors, everything from societal spatial planning, economic analysis to road constructions and underground infrastructure and whatnot, and digital services, which is the division that I work in, where I am head of research and development. So that would be me.
That's you, Runar. Very nice. And Raitis.
Hello, my name is Raitis Beziņš. I live in Latvia and work in Baltic Open Solutions Center, a company which specializes on creating map applications and applications which deal with sensor networks and GIS in general. I am a software developer and also one of the lead developers for Aegis Layers mapping application or mapping library.
A technical person.
A very technical person.
A very technical person. Carol, how about you?
I don't know what I can tell, yes, because I cannot compare myself with Runar or Raitis, because I was many years ago technical person. Now I am only sometimes generating some crazy ideas and pushing people to do something. Yeah. So this is probably one from the minor roles.
Yes, but you are in the field of open source, open data.
Yeah, in Open Geospatial Consortium, Research Data Alliance, and other organizations, International Society for Precision Agriculture. So I am more speaking than doing.
Well, the speaking has to be done too. So, I am also from Norway. So we have two people from Norway here today. And my background is from Earth observations, I would say. So a specialist, if you can be a general specialist on Earth observations or everything Earth observations, but particularly interested in making data interoperable. I have to say this is one of my babies. I'm a member of the Committee of Plan for All, and Carol and I, we met in the context of Inspire conference, I believe, and we started the Inspire hackathons in Barcelona in 2016. So that's a little bit of background of us, and now we can start mapping. Who is going to do that? That's Runar. And we turn off our cameras while you are speaking, and then if you have questions, you can ask. And if you have, I just have to say that if you have a webcam, a Chrome browser, a good internet connection, and a headset, you may raise your hand and ask your questions inside the webinar room, in addition to ask questions in the chat. The floor is yours, Runar.
Yes, thank you. So in this little section, we're going to look at something that we call map whiteboards. And we're going to speak to you about this, divide the time between the three of us a little bit on different sections. And just to say that while we come from very different parts of Europe, we all have in common that we belong to some siblinghood called Plan for All, which is an association that sprung out of a project that we participated in, all of us, many years ago, and that is presently catalyzing, facilitating the creation of new research and development initiatives, and operating a few pan-European data sets that could be the starting point of quite a few interesting analyses. I don't know how interactive this will be, but the there is a section towards the end of this webinar, which shouldn't be terribly long, where there is a possibility for discussions. So we'll come back to that. And if you have any questions, as Ben said, just ask them in the chat or raise your hand or interrupt as you like. It would be nice. So the webinar will include sort of 6 different parts. There will be an introduction that sets the scene for why we are building these map whiteboards. That will be followed by a demonstration that shows you how this works and how mature it is at the moment. Then we do a little bit of dive behind the technology to show what it is, why it was developed, and how it works purely technically, before we proceed to discuss a little bit how this could fit into existing value chains, how this could solve any problems that we may be suffering from in the world today in some little way. And finally, to round up with some discussion. So as I said initially, am Norwegian, but I am stuck in Belgium. So if there's anything that is particularly COVID about me, that would be having been landlocked here for the past 6 months, which is the longest time that I've been in a single location. Since I was 18, I think. For 22 years, I've never been this long in a single location. So now, as most people who think that they've stumbled upon something smart, we would like to make it sound as if this smart thing was the result of a very well thought through and systematic thinking and process that have led up to this. So we are sort of trying to retrofit a scientific narrative to the idea that we have arrived at. But more than anything, I think you can say that the motivation for doing what we have done here is that we think it looks a little bit cool. I mean, it looks like something that is interesting, something that we haven't seen before. So you should take what you hear here with a pinch of salt, and think that, okay, that there is a core of something new and interesting here, but the level of scientific sophistication might not be as deep as we would have you believe. However, the setting of this is that we feel there is a gap in our use of spatial data. And what we see is that we do share data and applications. Over the past 20 years, we've grown quite mature when it comes to data sharing. The first barrier that was torn down was, of course, map licensing, the politics of sharing, not the technical problem. The second and most successful catalyst for information was probably not data as such, but the invention of the web map service and the concept of tile-based maps. But strangely, these pre-digital methods of data sharing have not really, or pre-digital is rather big claim, but these pre-web map methods of data sharing have not really decreased. Surprisingly, the Esri shapefile is still the common staple for exchange of data, and surprisingly, the CSV file, the pure text file, has made a big comeback, much propelled by all the data that are made available in public sector information.gov style data portals. We become quite good at sharing web map applications, and those applications come out of two camps. There are those that come from the professional GIS environment that tries to emulate professional GIS functions onto a web interface. Those are generally shunned by the public because they don't understand all the concepts and so on. And there is the other angle of applications, those that stem out of pure visualization, so the type of applications that you build on top of Google Maps and Apple Maps and Bing and OpenLayers and whatnot. And map applications are quite nice, but they don't give you the same thing that a map gives you. They give you often a blank canvas or a blank background map that it's up to you to select from some sort of a menu structure that is individual to each different application to try and put things together. And that makes it a very good tool if you know what you want. But it doesn't tell you a story. It doesn't do what the map does. So we haven't become so good at sharing maps. We've become good at sharing applications. We've become good at sharing data. But for maps, we still print. We still send PDFs. So how about creation of data? I think that's an area where there is no doubt that there's been definite progress. All the satellite missions create more data than anyone could process on a daily basis, and much of it is freely available to the entire humanity. And while Landsat, of course, is still very much in operation, we, as a European, it's sort of incumbent upon me to show the Sentinel satellite here. We also become quite great at creating data, not just photo sensing data, but creating them. And I think one of the efforts that deserves a particular shout out would be the humanitarian OpenStreetMap, which has shown how you could scale these crowdsourcing efforts to meet a sudden urgent demand that arise from a situation, from an occurrence, something unpredictable. So I think in data creation we have made some progress. But once big problems have been solved, new ones appear, and albeit these may perhaps be smaller and less significant, it's still relevant. And one of the things that this map whiteboard plugs into is the way we create user-generated content. Nowadays, this is mostly a dialogue between the individual user and the application that he is using. And then, of course, as time goes, he is able to see whatever data other people have created, but it's not a collaborative process between multiple peers working together on the same area. And thus, for people to cooperate, two people should typically be in the same room or sharing a screen or whatever it might be. And this is something that we think the map whiteboard might enhance. While we have become good at creating data, we have not become very good at creating maps. I think our usage of maps is above and beyond anything it used to be. But if you compare the specimen on the left to the specimen on the right, these two are representative of two eras of cartography several hundred years apart, and I think we can all agree that this is possibly regress. What we think is that by building maps together, we would be able to make things that would be both functional and possibly more beautiful. That will not be a major topic for today, though. The next thing that we see, which justifies this map whiteboard technology, is a process that we see and that we saw in 1985, we saw it in 1995, we saw it in 2005, 2015. It's a process that really, really doesn't want to die. Somewhere in some deep, dark recess of government offices, there will be a large format plotter. This one will inevitably spew out large amounts of papers that eventually a number of gray planners will huddle around over a meeting room table and make notes on with a marker. They will point, they will be discussing stuff, and eventually these manuscripts will be handed back to someone who may or may not have been part of those discussions, who may or may not have understood what was meant, but whose task it is to encode this back into the map using a GIS tool. And this also strikes us as a process that could, with benefit, be shortcutted. So, if we look at these challenges in the light of the current pandemic or the UN Sustainable Development Goals and so on, it is conceivable that these could be classified as first world problems. These are not necessarily the things that needs to be solved for people to stop dying. But okay, we will go through our two different concepts now, and we will leave you to judge whether or not these are important. We believe they may have a space. And the two technologies we're going to discuss, one very briefly, one more in depth, is some way of describing, storing, and exchanging a map between multiple parties on the internet, consisting of stacked layers of information. And our current candidate for this is a technology that we call map compositions. The other technology is some way of enabling client-to-client interactions for common GIS tasks and data capturing. And our current candidate for this is map whiteboards. And once I have been speaking and making this suitably obscure for some time now, we are going to jump on to the Latvian Alps, where Raitis is sitting ready to give you a demonstration how these map compositions might work. So with that, I hand the microphone and the screen over to Raitis.
Yeah. Thank you very much, Runar. If you have questions to Runar, please ask them in the chat and we can answer them in the next break.
Yep. So I will a little bit demonstrate you the software which we have been developing in this hackathon. So this is a demonstration of the map whiteboard, which is not really just a test case, but also a real working application, which is still under development, but already published under a domain and is being used. So this application is meant for building models. Either there are process models or some problem trees where people can build those models together, collaboratively, and it consists of these kinds of charts and a map window. And the map window is shared between the users of the system and provides real-time drawing possibilities using the map whiteboard library, which we are developing. So I will try to fit two browser windows in parallel on the screen. So they can be on the same computer or they can be on different computers. And at the top, you can see I'm logged in with two different users. And whenever one of the users draws something on the map, which is done here using this draw toolbar on the top, where the user selects the layer, areas of interest, for example, then clicks the polygon drawing tool, and when he moves the mouse, it's visible on the other window, and vice versa. So that would be the pointing functionality. But drawing functionality is also done like this. Whenever a user draws something, it automatically displays on the other computer. So a collaborative drawing process is being made. And this mapping application is provided by two technologies, which have been integrated into a container application. One of them is the map whiteboard library, and the other is Aegis Layers, which provides the GIS functionality like layer manager, drawing, loading data from different sources, and other printing or sharing the map, for example. And we also can sketch on the layers, and some of the layers are configured so the drawn content is stored in the database and fetched next time somebody opens the application and selects the model. And some of the layers are, like, for example, sketch layer or cursor layer. There are temporary layers, and the content for those is not saved. It's deleted when the page is refreshed. So that was a quick demonstration of the map whiteboard. And now I'm gonna talk a little bit more about the map compositions, the other technology which enables this functionality. So map compositions can be viewed as a sort of project files in some GIS software, and they bundle together layers and meta information or metadata and other information which is used to serve the user a complete map which consists of many different parts. And the beginnings of this technology or concept is quite humble. We just needed a way to store the current state of the mapping application between reloads of the page. So whenever user draws something on the map or adds some layers to the map, which can be from some external servers, for example, this content needs to be saved between the reloads, or if he closes the browser. And at the start, we were using the OWS standard, and before that there was even an older standard from OGC, because but it was based on XML encoding of this data, and not really very easy to work with, because the applications which we are developing are mainly created in JavaScript. So we started to experiment with having our own kind of a standard, or for encoding these map compositions. At the right side of this slide, you can see the panel which is used in Aegis Layers applications to create these map compositions, where the user enters the title of the composition, specifies the current map extent, or these coordinates which define the bounding area, and also ticks which layers he would like to store in the composition and then on the server. These layers can be WMS services or GeoJSON or different other vector formats, and also ArcGIS layers. And maybe you will see some more example of that in the next slide. And currently the mapping compositions are supported in Aegis Layers, also in a software called Layman, which is used for uploading different vector data files like shapefiles or GeoJSON to server and converting them into OGC compliant WMS services, which is the best way how to serve the mapping content. And also under there is mentioned Mitska metadata catalog that also can read those compositions and provide metadata searching capabilities to the user, so to find something interesting based on some topic or some keywords which the user then uses in the search. And also I would like to mention QGIS plugin, which is used to create these map compositions in QGIS software, where the user adds some layers to his project. They can be raster or vector layers, and then is able to package these layers or this project into the map composition format, and then send it to layman to store and to make the content publicly available as a whole package, not just the individual parts of the of this map. An example of map composition looks like that. If visualized in Aegis Layers application, this was used in Liberetz's Atlas software, which provides different maps for more for education of the children in Liberetz's region. But I think they are also very interesting for the average geoinformatician. And on the right side, you can see the JSON structure of the map composition, which contains an array of layers, where each layer has some class assigned. For example, here you can see the WMS class, and that tells how to render this layer in some application which is able to handle WMS layers or vector layers. In this case, we are using that in open layers through the help of Aegis Layers application, because this map composition file still needs to be parsed, and the underlying open layers objects need to be created by something. So that's where we come into this whole setup. And map composition files can be validated using a provided schema, but that's more meant for validation if this content will be parsable by Aegis Layers. So we are not in any way trying to restrict anybody how to encode the data in the composition if they are able to parse it and then display it using some other libraries, for example. Back to Runar.
Very good. I shall steal the screen back and see if we can continue where we left off. With a little bit of luck, you should not be...
quick question from me. Sorry. So, sorry. So what you showed is actually creating maps the same way we are co-editing in Google Docs, for instance, online.
Yes, that was the thing which I forgot to mention.
Yeah.
Basically, Google Docs for maps.
Exactly. I just wanted to make that point. So.
And maybe that I can add, when Raitis mentioned QGIS, our dream for future is also to integrate QGIS into this whiteboard concept, but it is some planned where for future.
Yes, and all of this is open source. This is built on open source, right?
Yes, it is based on open source technologies.
Yes. Okay. Runar, sorry. Go ahead.
No problem. Very good. So now I'm going to give a brief description of the reasoning behind this map whiteboard. You've seen how it works now. The term as such is not patented, and it doesn't mean anything, and it might not be the final name of whatever this might be, but let's call it a working title for the purpose of this seminar. This is then a peer-to-peer technology that is not used for chatting, not used for downloading music, not used for any sort of illicit purpose. It's simply to stream map events, map interaction events between two different computers or 2, 10, 100. The usefulness of this technology is probably greatest in the interval of 2 to 7, 8 different users. If you have too many people working on screen at once, it's impossible to have an overview of what's happening. But the ideal scenario is probably on 2, 3 people collaborating. useful scenarios are probably up to 10, 15, something like this. The trick is that when someone moves their cursor, I can see it on my screen. When someone draws a feature, I can see it on my screen. I can edit what they have drawn. They can edit what I have drawn. But to create such a thing, there is a certain number of things that have to exist first. We wanted this because, first of all, I mean, we are simple people. We like to see things moving on the screen. And the first place where we saw these sort of things were in fleet monitoring. And principally, it's exactly the same, because you have something that is remote that streams to you its location. In fleet monitoring, it would be a truck. In our case, we are streaming the location of the cursor of other people connected to the same map. As Bente mentioned, Google Docs is sort of also a major inspiration, because in the past few years we've been working collaboratively on creating quite a lot of research documentation. And this used to be a terror, where we had to sit and edit in 50 copies of a same Word document, and only God would know what was the final version of each paragraph when someone tried to put this together in the end. But we saw that this Google Doc environment, where multiple editors could work on the same text, on the same word, on the same paragraph simultaneously, by means of streaming interactions between the clients, worked. Then all of us came from this GIS environment where we worked a lot with user-generated content, and we saw that, okay, yes, it was now possible to create technical, good quality geographical data from a smartphone, from a web client, and no need for professional GIS tools. But still, there is often this situation that there is one person who knows the landscape, who knows the ground truth, and there is another person who knows technology. And by having this map whiteboard interaction between them, you would be able to combine those two skills. One person who knows how to create data would be able to work together with another one, and by seeing each other's cursor, being able to adjust each other's data, you would have something. Another thing that has become increasingly relevant this year is that we have spent too much of our lives in online conferences and webinars. And this would then also be a typical good supporting mechanism for that. And of course, then there is an irrational component to this. We like to see stuff moving on our screens. So that's also something to keep there. The technical architecture of this, and I'm showing this simplified now, right? Is going to do a little bit of a deep dive into it afterwards. Essentially, you have one or more, well, one is pointless. It's two or more clients connected to the internet to the same web application. This is an HTML5 application of some sort, and it can sit on top of map clients built in open layers and map clients built in leaflets. It's currently mature only for open layers. That means that you don't need to use a client that we have developed. You can plug this into your own application and just add the map whiteboard functionality as a control into your map. So this is a library that can be added to any application. Each of these applications then start listening to and transmitting user interactions between the connected client and a server. So our solution has a client part and a server part. To store the data remotely, I mean, because as Raitis just showed you, this is not just for drawing and then erasing it. This is for creating persistent data that we capture over time. So to store this data, persist them remotely on the server, we use map compositions. And that gives us the flexibility of storing both geographical data and stacks of map layers. So that means that when one interaction could be for me to move the cursor and draw a polygon, another interaction could be for me to add a WMS layer to this map. And immediately that layer would also be added to any other connected client. And in this way, we could enrich the base map that we create data on with relevant information. To To stream these events, we use a technology called WebSockets, which is a protocol level thing which exists in all web browsers and web servers, or not all, but most. The application is hosted using Node.js, Express Web Server, and a library called Socket.io, which handles the WebSocket communication. And data on the server side are streamed to MongoDB. You will get more details on this afterwards. When we built this, it became evident that from very, very narrow, I should say, simple beginnings, we needed to expand our complexity quite quickly. We needed to be able to handle authorization, because we can't have only one global map that the whole world is working on. Everyone has to have their own document, similar as you have a document in Google Docs. Everyone has to have their own map. So we need a way to handle who has access to them, who are allowed to do what with them, who can see them, who can edit them, who can do both. It's necessary to be able to upload and manage these maps from different sources, so hence the integrations with QGIS and whatever. And it must be possible to download the data again once you have made edits. And then, of course, there comes all the peculiarities of streaming these different interactions. That means that with this API that we implemented, in principle, this could be considered a standard protocol. Now, standardization in the world has gone perhaps too far in some domains, and standards decrease in usefulness with increasing number of standards. But once you have a standard, once you have 300 standards, the next logical step is to have a standard of standards. So, you know, the value of integration sort of goes away then. So at the present time, this is an application feature, but it is something that is capable of communicating across different applications. So we're not locked to a single client. That's the point we're trying to make. So for a dive behind the scenes here, Raitis will get back the screen to tell you a few fairly technical things before we proceed to discuss the potential value creation that could arise from this.
Yes, well, they will be quite technical. So, Bente, you are free to interrupt me whenever you see that I'm running over the time. I will have something like 5 slides, and they will consist basically of activity and structure diagrams of the whole system.
Yes. It's I think the application is trying to connect. Maybe you should unshare, Runar, and then start over again. So meanwhile, this is a tech warning or a geek alert.
I see my screen shared a couple of times, like
I see it's something happening. Is everybody seeing the screen?
I see Raitis' screen disappearing into the eternity with showing the. Now I see his PowerPoint.
I do not.
I can stop and try sharing.
Yeah, can you stop? Both of you stop sharing.
I'm not sharing.
Yeah, and I re-enabled that.
Yes. Okay.
It's working. Yes.
Yes.
So the whole architecture of this application is the modular application, which integrates the whiteboard and other parts, looks like this. This is the diagram generated from the server-side components, Docker components or Docker containers. So basically, at the very top, we can see the databases where the data is stored, and the map whiteboard part is the PNB whiteboard server, and this is used for synchronization of all the information between the clients which connect to that, so to the users. And that runs the socket server and also the REST API to get the data and publish the compositions, for example. And PNB whiteboard server and also the user interface or you can see model builder UI, connects to another API endpoint, which is used to store the user information or the accounts, because the Whiteboard server doesn't have its own user management system, but it relies on other servers to provide this authentication mechanism. It can be OAuth 2, or it can be, in our case, we are just using some GraphQL endpoint which queries the current user session and user information like the username, email, and such things. So that's where we get the data from the model builder API. And of course, some Nginx endpoint manages that in the at the front of the whole system here. So the authorization process is quite simple. We are currently not using OAuth here, but we plan to do it in some other applications. But whenever the user signs in the interface, some authentication request is being sent to the modeler or the container applications API. Then the user info is returned if the authentication was successful, and we send again the same credentials to the map Whiteboard libraries server, and that in turn again sends its own authentication request to the same API endpoint, and again gets the user information back to it. So at the end of this whole process, both the map Whiteboard server and the front end of the whole application gets the same user information. So that will be then used, for example, to manage access rights for the compositions, or store the user or link the composition to some user when he's creating the composition, so we know which is the author of the composition or which is the author of the feature which was drawn on the map. And publishing composition process looks a little bit more complicated. Whenever user selects the model in the user interface, at the top corner, which of the demo application, which I was showing you before, but it cannot be. It might not be a model in other applications. It can be anything for which we would like to create a composition. So when he selects the model, then the application sends a request to the API, and then gets back if some map composition already exists for this particular model which the user is working on. And if it doesn't exist, then it needs to be created. And the creation of the map composition is currently done in Aegis Layers library. So that takes all the layers which have been added to the map. Either they are WMS layers, some GeoJSON files, vector layers, or some other types of layers. Then assigns some metadata to that, and gets a JSON document, which is then pushed to the map Whiteboard server for storage. And the server then returns an ID of this composition, and we can link this ID to the model in our container application. So if the user was editing some composition for a model called, I don't know, COVID crisis or housing crisis or whatever problem he was modeling at that time, he can then link different compositions to this model. Just one composition per model. In case the composition already existed in the database for this particular model, then we get its ID and then request this ID from map whiteboard server, which you can see in the diagram at the bottom. And the map whiteboard server then returns the composition file containing the layer definitions, which need to be added to the map application. Either it's in AGES layers NG or the underlying open layers map. So some layers, base layers or vector layers on which the user will be drawing are added to the map. And when the layers are added to the map, we need to fill them with features. In some cases, these features can be quite many. So we are requesting them one by one for each layer, not returning them together with the composition at the very start of the loading process. Because in that case, we would need to generate some very large package, or the composition file would be very large, and that might be not such a good idea. So we are downloading them in turns. We are first requesting the list of editable layers from the whiteboard library. Then that in turn connects to the whiteboard server, gets the list from the compositions file, which has been stored previously, then loops through the layers, repeats the same request for all the layers, and back from the whiteboard server, it then gets the GeoJSON file containing the feature collection. And then whiteboard library adds these features directly to the open layers or AGES layers map. And the feature propagation, which is done through these WebSockets, which Runar previously mentioned. The process is like this. The user draws some feature on the map. Then this feature is serialized into GeoJSON format and then sent to the whiteboard server via WebSocket. It is immediately stored, and some link to the layer and composition is made for this feature. It is stored into MongoDB because it's quite fast, and the overhead of these transactions is really small. Well, maybe the safety of storing this layer is a little bit lower than it would be when we would use some transactional database or SQL-based database. But on the other hand, it's much faster to store some simple data into Mongo database. And also, we don't need to deal with the overhead of converting data from GeoJSON or JSON into some format which is used for the SQL database geometry column, for example. And when the feature is received in the server, it's being propagated to all the clients which currently are connected to the same composition. So whenever some browser or client connects to the composition, it's saved in the user session, and the user can view at the same time only one composition. And the server sends these features to all the clients. On the source of this feature, or on the computer where the feature originated, where it was drawn, the feature is then ignored. It's not added again the second time to the map, but on all the other clients, it's added to the map. And the same thing happens also for the modification of the features. Either it is geometry, or it can be also the features attributes. And this process is quite fast. We are streaming the cursor locations every 15 milliseconds. So it of course depends on the network which the user has, and also on the distance to the server, the latency, I mean. But yeah, it is pretty fast. It's almost real time. And for features, we are currently not throttling the feature propagation in any way. So we try to push them to server and then propagate to the clients immediately. But probably when the usage will increase, then we will need to think of some way of throttling the request. So not too much data gets sent to the server, and not to crash the servers or the network infrastructure. So that's it from me. Thank you.
Thank you very much for this very educational class, I would say. So thank you. Do you have any questions? Don't be shy. I'm sure we will be able to answer some of them, at least, depending on how deep they are. Meanwhile, Carol, you are going to talk about the potential for value creation using these tools.
Okay, my part will be not so technical, also I think not so long like previous, but together with building this technology, of course, we are trying to thinking where this technology and how this technology could be used, because to develop the technology and not have any ideas about potential usage of this technology, I think that this is the mistake. So we discover some number of areas where we plan to start build solution and to offer this, and of course the importance of such technology is increasing now with the COVID and with the reduced possibility to move and meet. Then such type of collaborative technology can have a much bigger chance than it was before. So we are discussing communication as, for example, there will be necessary to communicate new ideas about some building, about some development of areas, and it is important to discuss this and share these ideas with the people. Or it could be also about new policies, like writers document show, and this is one possible market where we are thinking. I personally believe a lot for agriculture, because agriculture is the area where we are working a lot, and now we are speaking about smart farming and all these things. Usually preparing some recommendation for smart farming, it requires some interaction of more people. It could be expert on earth observation, it could be agronome, and it could be farmer. And to be the work more effective, they need to share the data and discuss. So why we have to prepare recommendation and increase the number or decrease of fertilizer in this concrete area. And I am sure that in such domains there will be number of cases where it will be possible use. It could be also used when, for example, farmer will discuss with the public sector, this request for subsidies or other things is cooperation. It could be in a project in other when some common ideas has to be shared. And of course, with this is related the science. Yes, many scientists from different places are working on the same problem. Now, I don't know how it is in your countries, but in our countries, schools are closed and students are working from their houses. So again, there is the possibility for such collaborative virtual technology where teacher can communicate with students and share with them the idea, discuss the problem online, not only making some hand drawing, but to share this data online. We have also idea to connect this solution in the future with some existing conferencing system and to offer this as the part for teleconferences where again often it's necessary to discuss some common problem, and this could be the way. And of course, probably one from the biggest area will be planning. It could be urban planning, it could be forest planning, where planning is process of interaction of more people. There is planner, there is public servant, there is some user, and they need to interact. Now, for example, in urban planning is very often such things that planner is preparing plans and people are coming to the municipality office or other places looking on them, writing their comments. With such type of the technology, there will be possibly to discuss and solve all these problems interactively, and we are sure that again this is some next future. I think that it is generally and very shortly about our ideas, and now I think it's time for some discussion next. I don't know, Bente, if there are some questions from participant.
Not that I can see right now, but I would like to remind people that they can actually raise their hand and come into the room and ask the question and go back and forth a little bit, if that is easier in terms of expressing your questions or your comments. We are also welcoming comments. So please do that. I have, you mentioned different reasons and applications areas, Carol. And of course, this challenge here is a part of the COVID-19 Inspire Hackathon. And what type of maps have you foreseen any maps to be made relevant for the COVID-19 situation?
We don't work so much with this. The part of hackathon is to support work in the COVID period, yes, and we are much more focused on the supporting work of the people who cannot go, who cannot meet, and who need some collaborative tools to be possible to solve common problems. This is more the task. I'm sure that they will be possible to combine this with some collection of some cases or other, but generally the main purpose was to support work of the people when people cannot meet.
Exactly. Yeah. So this is a tool to mitigate the fact that we cannot meet, and even perform like territorial planning and science and all the areas you mentioned. Okay, then I understand that's the main purpose by developing this tool. In fact, the tool itself.
Yeah.
Any other questions from the others? I mean, you are all mentors in this challenge number 5. Is that correct?
In principle, yes.
In principle, yes.
Mentors and developers.
Yeah. No, yeah. would you say that people are welcome to join you now?
Yes, they can join us, and we will be very happy also to have more people with us who will come with the business ideas. Yes, we would like to speak with the people about potential business ideas, because we have something in the mind, but could happen that people will be able to discover something new, or you have some problem, and we can discuss how we can try to help to solve this type of the problem, because this is important task. And as I mentioned, yes, technology is for nothing if there is no use case or businesses.
Okay, so there's a twofold here. One thing that people are invited to do is to actually help further develop the tools to make sure maybe that is user-friendly, test out different functionalities, etc.
Could be also to try to discuss with us and connect it other platforms, yes, because okay, they are all are open source platform, but if such solutions will be supported by more platform and other platform, there will be again a much bigger added value. Right, is also discuss this topic of map composition, which we are using for sharing of the map. And again, there we will be happy to speak with other people, because we know that they are similar but different models. And again, it will be nice to sit together and unify this model. It is also related with other challenge 3, which is working about this, and they will be very nice to build the community around these problems and to discuss how these problems can be shared among different platforms, because we don't expect that they will be one platform for all world. And if more platforms will share, this is the task, because some openness and cooperation is something what is also needed.
Yes, absolutely. And the second part that I wanted to highlight. So one thing is developing the technical part, among others, connecting to other platforms. But then also you mentioned that there's a possibility to take, based on this platform or this technology, you can develop business plans to create some services.
Yes.
Yeah. So there's twofold. There are at least two ways that you can engage in this challenge. So I can just say one thing, and that's that sharing a map, and some of the map solutions that the counties have in Norway. I don't know if you looked into that, Runar. You might know them. They are, to say the least, not optimal.
Well, there is this breakpoint, as I mentioned, between the internal view of what a map should be and the public view, which one of them comes from ArcGIS in the 1990s, the other one comes from Google Maps, if you look at it broadly speaking. And they don't really agree. There was a whole language invented around this first desktop GIS that people have been trying to bring into the web GIS sphere, and that has constitutes a barrier for most sort of interactions. But now we see sort of spatial functionality popping up again, more and more applications that are not predominantly map applications, but they have a map component. And I think this is part of that ecosystem. It's something that could be made part of an application where you don't really need a PhD to be able to understand the whole concept set, and where you're simply thrown into it. And we have made, I mean, somewhat of a pig's breakfast out of explaining this in an easy way, right? We have explained it now from a fairly technical perspective, assuming that this would be the audience here. But using this is extremely straightforward. No, it's not a very complicated thing at all. It could be highly intuitive, but then of course it wouldn't be an hour.
I have by the way, before I forget it, I had a questions with respect to maps, because you mentioned different types of maps, or ArcGIS and Google Maps. And what you can see is that the resolution of these maps are very different, and the content of the map is very different. So this tool that you are developing here, you know, in terms of details, how far can you, the resolution is, are there any restrictions with respect to resolutions of these maps?
No, it is absolutely free to use it for any sort of resolution you might like, but in WebGIS, of course, which sort of emulates this old universe where people were sitting trying to digitize on big paper maps on digitizing board. At that time, you had a fixed zoom scale. Nowadays, we are lazy. We don't like to do stuff. We were lazy then also, but there weren't any alternative. But the trick is that now when we want to put a map with a dot on Prague, we are quite satisfied when we see all Europe and we drop this dot. The fact that this dot ends up 300 kilometers away from Prague doesn't matter so much, because the symbol that we use to represent it anyway covers the whole Czech Republic. So the accuracy of the data determines a little bit the discipline of the user. But once again, that is an area where you would be able to do this, because I sit here with my brilliant mind where I know a lot of stuff about a specific area in Norway. Right as he drops the cursor there, I can switch it around a little bit and shift it to the correct position, because I know that territory. So people can collaborate across different spheres of technological and territorial knowledge.
Yeah, so
once again, wrapping something very simple in complicated language. But yes, I mean, it allows people to hone their skills where they're useful.
Right, and also have a high resolution. I was just having this experience, by the way, on Facebook and my company page, and I was asked to put the location of my enterprise on the map, and then you had a low resolution, you know, like not entirely Europe, but and you put your pin there, and then you zoom in and you say there you are nowhere near where I live. And then you could actually zoom in, so I recognize the topography, at least of the lake. I live by the lake, so I could, because I knew where my address was, I could pinpoint that. But it was like I was not sure. I was, just because I'm curious and love maps and so on, I was experimenting, but I could have been, you know, oh, okay, like you said, I put Prague is here and it's maybe in the, not even in Czech Republic, you know, if you choose the wrong resolution of the map, but you are perfectly happy with it.
I think also the challenge for the collaboratively generated maps is the data to be topologically correct, so the polygons will not overlap with each other in case in places where they shouldn't overlap and such.
Yeah, because
I think we can say that until now we store an insane amount of decimals. I think we have 14 decimals for latitude and longitude in this thing. So the theoretical precision is at least not limited by the platform, I think we can say.
Right. So if I want to sculpture my property, then I would be interested in the topography as well.
Yes.
Right. So that's one application area. So if you in this time, as Carol says, we cannot meet, I have a landscaper that I want to sculpture my property, and I want to interact with she or he, and then of course we could do that live on this mapping tool, but having a topography included. You see,
so you're painting an interesting picture of your life now. You live by a lake. You have a butler who normally talks to your landscaping people, but you would like to talk to them directly for a change. You're painting a very strange picture of Norwegians. We are known globally as egalitarian and very much into equality. This is you're ruining 100 years worth of marketing here.
Suffering and poverty, only eating potatoes whenever we find one.
Yes.
Yeah, no, this is my life, Runar. I have to deal with all of these people, and I don't, we cannot meet anymore.
No, I understand. It must be a terrible weight on your shoulders.
Yes. So I welcome challenge number 5, and you all should do that. You see how helpful it can be. Yeah. People are very shy of asking questions, and they are not raising their hands even. So maybe can you provide them with in the chat somewhere they can connect with you? Because we have some people in the audience, maybe they are really hardcore coders and technical geeks. They might prefer to send you an email or connect with you on some platform. Do you have any emails to share in the chat box with them so they can?
Okay, I will share my email, and if anybody will be interested, he can connect with me, and I will connect this with the rest of the team. Because my colleague asks crazy technical guys, usually they are not answering so often, so I will try in such cases to make the bridge. Yes.
Are you calling righties crazy now?
Bente, I have to say, I like to have around me crazy people, because normal people have only normal ideas. Yes. Crazy people can have crazy, brilliant ideas.
Yes, and we like you, crazy Carol, as well. So we are all crazy in this room, I think. Yes. So welcome to Craziness. We can now share maps and explore how to make even more fun maps and more useful maps, with or without a butler. Yes. You see the email. So thank you so much for your attention. Thank you, all speakers. Do you have, Carol, you have a last word?
That recorded video will be available on Plan for All web pages, and what I know that Hanka is now publishing progress report from any of the challenges. So please follow Plan for All web pages. You will have chance to see what is doing and what is the progress in the single challenges, also including this our challenge.
Yes.
I have to say you goodbye, because in 15 minutes for me starting as a webinar about EUX project. It is we have series of final webinars because this project is finishing. So because I'm moderating this webinar, I have to move fast there.
Yes.
So I was happy to be here, and we will of course we will meet soon again on some other webinars.
Yes, we will. Thank you so much. You have the links in the chat. Until next time, follow us on Twitter as well, Plan for All on Twitter, and also visit the website. Thank you, Runar, Rightis, and Carol.
Thank you. See you. Bye.
Thank you. Have a nice day.
Have a nice day.
Bye. Thank you.